Guys, how you doing? Right now we're gonna be doing the long awaited for midterm review. So I haven't really done this. Well, it's not I haven't done this. I'm gonna do it right now. So I might make some mistakes. Just don't. So like my answers might be wrong. Now I doubt, but for maybe the coding questions, I'll definitely make mistakes. So take it with a grain of salt. Okay, let's head right into it. Which of the following best describes recursion? Remember, recursion is making problems smaller and solving the smaller problems. So dividing a problem into unrelated parts, obviously they're related, or else why would you split them? A function calling itself to solve subproblems. It doesn't call. Okay, let's read the other ones. A function calling itself to solve smaller instances of the same problem. This is probably more like it. It kind of explains it better because smaller instances of that problem, which is the same thing as saying calling itself to solve subproblems, but I don't know. So I'd probably go with C on this one. What is the primary advantages of using recursion over iteration? Recursion is faster than iteration. That is false. And in some case, well, yeah. In some cases, recursion is faster, but not in all. So that's that. Recursion simplifies code when breaking down complex problems. Yes. So this is probably more like it, because sometimes when it's complex, it's better to use recursion than a for loop. Sometimes it's even impossible to do with the for loop. You have to do with the recursion. Recursion reduces memory usage. That is false. Recursion usually increases memory usage. Recursion eliminates the need for variables. That's not necessarily true. It really depends on your case scenario. So I'll go with B on this one. The reason it doesn't reduce memory, because remember, when you, for example, you do a factorial problem of factorial of 5, right? If you do the recursion case, it will be 5 times the function call of 4 factorial, then 4 times the function call 3 factorial, and this is in the stack until this gets resolved. But this won't get resolved until this gets resolved, and this one, and then so on. So it increases memory instead of save memory. What is an essential feature of a recursive function? A base case to terminate the recursion. That is free marks. If you guys get asked that and you don't get the right mark, please unsubscribe. A base case, you always need a base case for recursion to terminate the recursion, or else you'll have an infinite loop. At least 2 parameters. That's not true. You can have any number of parameters. A loop structure. Well, sometimes you'll have a for loop and even while loops within your recursion. But it's not like an essential. A global variable, no, like it's not an essential either. Which problem is best solved using a recursive approach? Sorting an array of integers. Sorting, yeah, like if you're doing, for example, a merge sort, yes, but if it's integers, you could also use counting sort, but that one is not a recursive function. So calculating Fibonacci numbers, we'll keep that in mind. Calculating the average of a list, obviously not. To get the average, you can go linear like a for loop, add them all up and divide by the number. Searching in a hash map, yeah, even this, like it depends really on your scenario. But calculating a Fibonacci specifically, because the Fibonacci number will actually get very, very, very slow if you don't use a recursion. Like extremely slow. And not only if you don't use recursion, if you don't use memoization. So keep that in mind. You will use memoization and recursion for Fibonacci to make it very fast. You can still do it recursively without memoization. Which of these algorithms utilizes divide and conquer? Insertion and bubble sort. These ones are in place sorting, which means they'll use the actual array, the array itself, to sort within the same array, like moving things within that array. So they don't divide anything. The merge does. If you guys remember what a merge is, if I go to my merge, if you guys remember what a merge is, it splits the array. So you see divide and conquer. And so that's that. So it's definitely the merge. A linear search, from the name suggests, it doesn't split anything. It's just a linear search. It's like a for loop. You're searching one element at a time. So this is definitely a divide and conquer. In divide and conquer, how is the problem typically divided? By iteration over a collection. Huh? Well, that doesn't divide. By breaking the problem into smaller subproblems. That sounds like a dividing. By combining unrelated problems, by dividing the result into two sections. So obviously, if you have the result, why would you break into two sections? That's the result you want to return. It's breaking the problem into smaller problems. Why is divide and conquer often faster than brute force methods? It avoids recursion. That is not true. For divide and conquer, you actually need to use a recursion. Now, is it always? I'm not sure, but I haven't seen an instance where you use divide and conquer without a recursion. It reduces the size of a problem quickly. So this is false, because obviously you don't avoid recursion with a divide and conquer. It reduces the size of the problem quickly, yes. It only works on small data sets. That's not true. It works on any data set. And sometimes even the bigger the better, actually. I mean, no algorithm works better the bigger it is. I mean, counting works better the smaller it is. The counting sort, if your range is small, it works better than if your range is big. However, the counting doesn't even use divide and conquer. Like for example, merge time complexity is n log n, and it's always like it's constant. Like it doesn't matter what size you give it, the time complexity will always be n log n. And so it's often faster than brute force because it reduces the size of the problem quickly. Requires no extra memory. That's not true. Like we said, divide and conquer does use memory. Now, unless you do a tail recursion, but it does use memory. Which of the following algorithms is not based on divide and conquer? A binary search. If you guys remember what a binary search is, binary search works on a sorted array. Here, actually. Divide and conquer works on a sorted array. So let's say our array goes something like this, right? If I want to find, let's say I'm doing a binary search and I'm searching for 7. Well, the way a binary search works is, well, first take the mid, and if like is 7 more than or less than? If 4 is less than 7, then we forget everything to the left. So we get rid of this. And then we take this and we divide it in half, and let's say we grab this, and we're like, is 6 less than? If it is, we forget all this. And so you see, it kind of divides it, but it's not in the typical problem of, like a merge sort, for example, is more descriptive. So what do we have? Selection sort is an in place, it doesn't divide. Quicksort uses a pivot, it doesn't divide it. Actually, quicksort does. Oh, it's saying not based. So I guess, yeah. So that would be selection. Because this kind of does use divide and conquer, like we said. Oops. Yeah, quicksort does use it because of the pivot, and then it splits the rest of the array in half. Merge sort, we already know that. What is the average time complexity of quicksort algorithm? So the quicksort, the average time is n log n. And your worst case, if you guys remember, it's O of n squared. And usually you get your worst case if you choose the low index, high index, or the midpoint. If you use median or random as your pivot, then you get the n log n average time. But if you're using, again, low, middle, or high indices, then you have a great chance of getting O n squared. So the average time here is n log n for quicksort. If you guys remember, what is the space complexity? Do you guys remember the space complexity of a quick? It is log n, or O of n. So that depends on how you code it up. If you use tail recursion, it's log n. Which sorting algorithm is stable? So when it comes to stability, you want to think about it regardless of what input or array I give the sorting algorithm, will the time complexity change? So we know the quicksort is not really stable because it depends on the pivot. So the time complexity is not stable. Counting sort is also not stable because if you guys remember, the time complexity for a counting sort is O of n plus k, k being your range of numbers. So depending on the range, the whole time complexity changes. However, for a merge, it's n log n. And so It doesn't matter how big the sizes you give, it will be n log n. It doesn't matter what you do to the merge sort, it will be n log n. And so it's the most stable one. Counting sort is efficient for sorting negative numbers, integers within a limited range, long strings, floating. So counting sort only works for integers. Keep that in mind, it only works for integers. It does work for negative numbers. However, it's efficient for integers with, this is the key right here, limited range. If your range is big, so let's say my array, so counting sort works better if my array is, let's say 1, 2, 1, 4, 10. You see, my range here is between 1 and 10. It will work very well for this case. But if I have less numbers, so the same amount of numbers, which is 5 numbers, however, my range is very big. So let's say I do 3, and then I do 1,000. Whoops. I do 1,000, and then I do 2,000, and then I do 100. So you see, my range here is between 1 and 2,000. Oops. Jeez. 2,000. So what is my time complexity for this? It's O of n being the number, which is 5, plus my range, which is 2,000. So it's 2,000 and 5. And the time complexity for this is O of 5 plus 10, which is 15. And as you can see, this is way faster than this. And so that is back to this one. The limited range does matter. And so it's efficient for integers within a limited range. What is the space complexity of a merge sort? Like we said earlier, it's n log n. The space complexity. The space complexity for a merge is O of n. It's linear. Because if we go here, merge. So if you guys remember this right here from the merge lecture, the reason it's linear, because you see, for every element in the array, you'll end up getting an array for each of those elements. So here I have, 7? Therefore I have 7 arrays. So if this is my graph, and here is the number of elements, then the size will grow. So if I have 1 element, my size will be 1, because, it's only 1 array. And so this is how it will go, linear. If I have 7 indices, then my space will be 7 arrays. And so it's linear. All right. So that's for merge. What is a collision in a hash table? I just did a lecture on hash tables right before this one. So if you want, go watch it. I do explain what a collision is there. When two values are hashed to the same value, when two keys are hashed to the same value, when two keys are assigned the same memory location. See, this one's a little bit tricky. It's very vague. When a hash table runs out of space, and when a key is not found. So it's definitely not when a key is not found. That has nothing to do with a collision. When a hash table runs out of space, that's when you get a collision. But it's not what a collision is. When two keys are assigned to the same memory location. The thing is, when you put a key into a hash function, it will give you an index. And if you give a separate key and it gives you the same index, that's when you get a collision. So it's not necessarily memory location, it's the same index. So the wording is a little bit like, when two keys are hashed to the same value. So I guess this one is more descriptive because they're saying two keys, you hash them, and they give you the same value, aka the index. So it's when two keys are hashed, and they give you the same index. That's what that says. Which of the following is used to handle collisions in a hash map? Obviously, it's not a binary search. What does that got to do? Remember, again, go watch the hash. That one explains it. When you get a collision where you have two keys are mapped to the same index, so let's say we have a array, right? So let's say that this is, actually, no, I'll make a new array. Let's say our array is 0, 1, and 2, right? And I have two keys, 100 and 102. I take these two keys and I hash them. And they both give me index 1. So when the hash map goes and stores at index 1, the way it will store it, you'll have a key value pair, right? Key and the value. So let's say this is the 100. And then since this gives you the same one, we will use a linked list to put that at the same index, which is 1, but link it to the first one. And this is going to be your 102 with its value. All right, so it uses chaining. What is time complexity for searching an element? What is the time complexity for searching an element in a hash map on the average case? It's O of 1. Remember, when you put in, that's my music, by the way. You guys should listen to this one. It's really good. No, not this one. This one. Anyways, back on subject. The time complexity for hash map on average. If you remember, hash map is just an array, and remember the value gets. Oh no, I came here actually. I can just explain it here. When you don't have a collision, this is specifically the average case. When you don't have a collision, and you put in the 100, it gives you 1. Your hash map will go to 1 in the array. This is an actual array, and so remember when you access things at an array, your speed is O of 1. It's instant. However, when you have a collision, it will search linear. It will do a linear search, and that's when it slows down. That's the worst case. So the average case is O of 1. A hash map allows you to store multiple values for a single key. That's not true. Quickly look up values by key. That is true. Like we said, it's O of 1. Sort keys in order. No. Retrieve items by index. No, you retrieve items by key. True or false? A recursive function must have a base case to avoid infinite recursion. That is true. We went over it a little bit ago. Divide and conquer algorithms split the problem into overlapping subproblems. Yes, that is true. Counting sort is useful for data with a large range of values. We just went over that. That's false. Range matters. It makes it very big. So it's not useful for large range. Hash maps generally provide O1 average time complexity for lookups. We just went over that. That is true. Okay, now we're doing fill in the blanks. There it is. So, what do we have here? An array sum. So we're trying to sum up the array. Our base case is when the start is more than the end. What do we return when the start is more than the end? We return the array at the end. Because if you return the array at the start, let's say the end is index 10. That is the last index in the array. If the start is bigger, that means the start is index 11. If you return something at 11, you'll be out of bounds exception. All right. Now, just like everything in recursion, guys, if you do a recursion, your initial array has to get smaller, or your initial string has to get smaller, or your initial number has to get smaller. You always have to make it smaller. Find a way to do that. So in this case, what we'll do is the way we make it smaller, since we have start and end, the next call I make, I'm then going to do the start plus 1. So if my start falls from index 0 to 5, and I did start plus 1, the next time I call it, it's going to be from 1 to 5. And so you see the array just got smaller. And so that's that. Let's see the array sum. Let's test it out. So we'll do array sum. The start is 0. Oh, I got to give it an array. Ugh. I actually forgot how to create an array. What is it? Int. I know it's like this. And we'll give it size 5. But I forgot how to fill it out. I guess for loop. For int num in array. We'll do, actually, I'll use a different for loop. Int I equals 0, I less than array.length I plus plus. And what I'll do is I'll just do array at I equals I. And we'll just get a sort. This is going to be a sorted array. So if I do system dot out array. Wait, I don't think this works. Can you print out an array like this? I don't think that works actually. I think you have to do a for loop and print every, yeah, it gives you the address. So I'll have to go through another loop. This one will just be easier. I'll just do system dot out num. And there you go. So we have 0 to 5. And so we want the array sum. Let's do that. So we'll do system.out.println, and then we'll do array sum, and we'll give it the array. We'll start at 0. Remember, if the size is 5, we end at 4. And that's about right. Let's do that. What is my sum? 14. There you go. So that works. Okay. What do we have? Factorial. Let's take this one down. Put this above. Static. Now for factorial, obviously we're returning an integer. When it's less than or equal to 1, we return 1 because factorial of 0 is 1 and factorial of 1 is 1. So that kind of gives away itself. Here, what do you do? So factorial, remember, you'll do, you'll be doing, let's say factorial of 5. What you'll do is 5 times factorial of 4. Then 4 times factorial of 3. And so what is my 5? That's n. Remember, when I pass here 5, that's my n. So n times the factorial of 4, which is n minus 1. And this will keep recursivating, or whatever it is, I guess. I don't know what the word is. But here, let's comment this out. And then here we'll do factorial of 5. There you go. Where is it? Did I print it? Oh, I didn't print it. Whoops. System.out.println. There you go. And so that's 120. There you go. So that's factorial. Fill in the blanks for a hash. So let's take this out of, put this in. Static. So don't forget in the midterm to import your hash in case it's not imported. Okay, so what do we have? We have word count. So you have a string with words, for example, hello, boy, dog, hello. And basically what they're asking you to do is count, return a hash map. So what we want is we want to return a hash map. So let's imagine your hash map is whoops. No way. Okay. Thank God. I keep signing in and it keeps logging me out for some reason. I don't know how to get rid of it. But let's say this is our hash and they want key value pairs where it's the word and its frequency. So each word and frequency. Word, frequency, and so on. Okay, so we know in a hash this is going to be key because if there's any word that is the same as this word, so let's say this word was hello, right? If this word was hello, that's my key. Every time I get hello and I pass it into the hash, it will give me this frequency. So every time I get a hello, I put in the hash, I get the frequency, and I increment it. That's all you got to do. And so what is my key? It's going to be string, right? For string word and word. So now I'm going through each word in the array. I want the current count. So the current count already tells you the frequency, the current frequency. So if I do count.getWord, which is let's say hello, and I've never added this to the hash, what I'll get is a null. Okay, so keep that in mind. If you try to get a key that is not in the hash, it gives you null. So I'm saying, is this word available? If it's not null, which means it is available, then my frequency is counts.getWord. That's my frequency, right? My current count. Else, 0. Because I haven't, if it's not in the hash, that means this is the first time I get to it, and so it will be 0. And then so now what I do is I do count.put, so the hash, I give it the word, well let's say it's hello, and then I do the current count plus 1. Alright, so that's that. let's test it out. We'll do word count, and then we'll pass it. Well, I gotta pass an array of words. So I guess, you know what, I'm too lazy to do that one. Yeah. But actually, here. No, that wouldn't work. No, screw it, that's too much work. This is the right answer though. Trust me, bro. Okay. This one is already solved, so I'll leave that one. I don't know why he posted it like that. Rapo's tripping, bro. He's drinking rum. Oh, my phone's running out of charge. Whoops. And I'm using it as the mic. Shit. Okay, plugged in. Fill in the blanks for a selection. Let's do that. Boom. Okay, so for a selection sort, the way selection works, if you guys remember, it is the most humanized way of sorting. So if you have an array that is random, right, 3, 4. If you want to sort this with selection, what you'll do is you'll have, what do you call it, your I. Your I is going to be at the beginning. And what you're going to say, this is going to be your minimum number when you first start. Right, so my minimum index is going to be at I. Right, then what you'll do is you'll have j. And j will start at I plus 1, so right after I. And then what you'll say is, okay, is j, well, j has to loop, right? J has to loop all the way to the end of the array. So this is going to be array dot length. And then if array at j is less than my minimum index, the array at the minimum index, right? If the array is less than the minimum index, which is currently 5, is 10 less than 5? No. That means increment. So this will go j, because remember, this if statement will never run. And now it will be 1. Is 1 less than 5? Yes. So what happens is now the minimum index becomes j. So now instead of it being I, this was the minimum index first, because remember of line 29. Now we switched it. My minimum index has become this one, which is my second. And so after all that is done, after this loop, the first loop is done, and I loop through the whole thing, and I find the whole, like the minimum index, which here is 1. Then what I'll do is, well, switch them between the old minimum index and the new minimum index. So temp is going to be array at I, array at I, and I'm replacing array at I with array at minimum index, or IDX. And then the minimum index will become the temporary variable. And so you see now, if I want to switch this to the other way, here, let's try to sort. So selection, let's get rid of the class. There we go. Static. Okay, now let's use it. So I'll have selection sort, and well, I want to print it, so system.out.print selection sort, and I'm going to pass it the array. Whoops, there you go. What's going on here? Method, return in the... Oh, well, I guess this doesn't return anything. Oh, and keep this in mind, in Java, the array doesn't... So when you pass an array to a function, it passes it by reference, not by value. So when your sorting algorithm sorts the array, it sorts the actual initial array you passed. So actually this changes. And so it's not like Python or C++ where you can pass it by value, aka you pass a copy and it returns you the value, and then you do, like your array equals whatever this returns. But in Java, it's passed by reference. And so this will, just me calling it, will change the initial array. So then I'll just print the array. Well, this won't print the array. I'll have to use this one. So Okay, so let's run it. And you see now it flipped it. So if I change this to that, it will flip back. And that's how we know it works. Okay, so let me copy this method. Insertion sorting. So for insertion, basically what you do in insertion is you assume your first variable. So here, actually, I'll just use this so I save some time. You assume your first number is already sorted. You assume this is already sorted. That's why your I is equals to 1 and not 0. Now this will keep going, obviously, until the end of the array. Your key is going to be this one, the first one. And so that would be whatever your I is at. Your j is going to be I plus 1. Or no, j is going to be I minus 1. Because the way it works is, remember, your I is not the first one. You're assuming this is already sorted. So your I is here. Your j is here. And so what this function does is, while j is more than 0 and array at j, so yeah, because it goes backwards. So while array at j is more than your key. So what I'm saying here, while number 5 is more than the key, is number 5 more than the key? No. And so that's how you know this won't run the first time. Well, at least for this array. Then let's see here. Let's switch these up so I can show you the example for when it does run. So let's say this is 10 and this is 5. So we know I is at 5 and we know j is at 10. And now what I'm going to say is j more than or equal to 0. J is at 0, so this is true. Then I'm going to say is array at j, which is 10, more than the key, which is 5. Yes. So if that's the case, then what I'm going to say is, okay, the array at j plus 1, which is the 5, equals the array at j. And so what I just did is I took the 10 and I shifted it, and now 10 is here. But the 5 is not totally lost because 5 is stored at this variable key, right? And then when I say j equals j minus 1, which is the same thing as if you do j minus minus. J will go minus minus, which will become negative 1. So therefore this loop will fail because j now is less than 0. And so now what does it do? Array at j plus 1. Remember, j is negative 1, so j is here. So I'm saying j plus 1, now I'm talking about this 10. This one now equals the key. All right, so now this becomes the 5. All right, and so that's how this works. So now let's comment out this one. And let's call insertion sort. And pass it the array. What's up? Oh, there you go. Let's run it. And now we have 0, but then the array initially is like that. So let's switch it around. Let's do in the other opposing order. Now you see it's the order flipped. 4, 3, 2, 1 instead of 0, 1, 2, 3, 4. And so that works. Okay, now we're doing some short answer questions. Static, let's return them. So we got rid of the error. Comment this out. Let's take this and then put it here. Okay, so what do we need to do? Write a recursive method to compute the sum of digits of a given non-negative number. So we want to compute the sum of all these digits. So we can say if n equals, that's our base case. Remember, like I said in the very beginning, when it comes to recursion, the way you do recursion is you want the variable you're passing in to go down. Whether it's a number, it goes down. Whether it's a string, it gets shorter. Whether it's an array, it gets shorter. So once our n goes to the lowest value it can be, what is it usually? You don't want it to go past negative because it says non-negative numbers. And so the maximum we'll get to is 0. Then when it's 0, you'll return 0. But when you return 0 and you add, in your recursion, remember you're adding these numbers. So adding 0 doesn't really do much. So if you don't even return 0, if you just do when n is 1, return 1, this will also work. And if you do 0, it will also work. But obviously there's no point in doing 0. You'll do an extra loop for no reason. Okay? Then what am I going to return? I'm going to return n plus the sum. So sum of digits n minus 1. Because remember, you got to decrement. You always got to go down. And so that would be it for this question. Pretty straightforward, I'd say. And so here what I'll do is sum of digits 10. Let's comment that out. We do have to print this out. Sys.out.print ln. There you go. And you see now it's 55, so that worked. Not that I know what the sum of 10 is, but we're going to assume I'm smart enough. So that's the second question. Okay. So here, actually, give me more space so I can make this a little bigger. All right, find the max. Write a method that uses a divide and conquer approach to find the maximum element in an array. Every time they tell you, here's an array, divide and conquer, you got to get the midpoint and divide it in half. That's literally what it is. And so what is your base case? When you have left and right, usually when your left is more than or equals to your right. So if the index of the left crosses your right, then you would return your array at that position. I believe for this case, you can say equals. Usually what I like to do is leave the base case for last after I write the function itself. So let's write the function. First, I need the midpoint because I want to divide the array in half. So what's my midpoint? So midpoint equals my left minus right minus left, or it's a plus divided by 2. Now for most people that see this, they're confused. They're like, why don't you just take the total number and divide it by half? The reason for that, because this is a recursion, when I pass an array, I'm not going to actually divide the actual array in half. I'm going to control where the recursion has access to between the left and right. So if I want to pass a shorter array to the recursion case, I don't cut this in half and lose all the values. What I will do is I'll have obviously my left, and I'll have my right. Right? So usually when you first start, your left is going to be at 0, and your right is going to be at array length, -1. So after, oh, my eye is itchy. So after the second call, if you want to split this in half, you just take the left, pass it here. And that cuts the array in half. So, 1 second. Okay, sorry. So now when you do that, that's how you shorten it. That's how we get the midpoint. And then what we'll do is we want the max, obviously. So we'll say, remember, this is recursive. So the first we'll split it. And we're like, find the max. Then we take this, split it, find the max. Then we take this, split it. And then we return. So that's how it works. So then what I'll do is I'll do int the left side. So the first split, right? You have your left side equals, well, this is going to be left side max. And we're going to call find max because that's the function we're writing. It's find the max. So if I want the max of the left side of the array, then I'll just say find max, pass the left side of the array, and get that, right? Like, it only makes sense. So I'll do the array. I'll do from the left, which is 0. This is the left side. And then I'll do to midpoint. All right. Then for the right side, I want the max of the right side. I'll do find max again. And now what I'll do here, instead of, well, the right will stay right, but the midpoint will be mid plus 1. The reason it's plus 1 because we included the mid here. So here you got to skip it by 1. Or you can include it here, but then you do this -1, but it looks nicer when you do here +1. It makes more sense. And now once you get to the last part, we have split the array in half. We have found the left side max, and we have found the right side max. So if left side max is bigger than right side max, then obviously the left side is bigger, so return left side. That's going to be the max number on the left side. And then else, if left side is smaller than right, then obviously we return right side max. Now that's one way to do it. You can also do return left side max more than right side max, question mark, left side. This is just the more precise way to write it, I guess. But both ways work. And so now let's see if that works. So we're going to pass the array. And so what we'll do is find system.out.print. And what we'll have here is we will call find max. We'll pass our array. We'll pass it 0, and we'll pass array.length -1. What is going to make it static? Oh, there we go. And 4. So as you can see, that does work. Okay, so write our recursive method that counts. Well, let's copy this first and then we'll read it after. Write our recursive method that counts how many times a given character appears in a string. So, your base case, remember what I said for the 5th time or whatever. In a recursion, you always want the initial pass value to get smaller somehow. Here, if they don't pass you an index, then you will use substrings of the string. You'll actually cut the string. If they pass you an index, you can just increment the index. So, if my index equals string.length, then I have reached the end and I'll just return 0. Right? Then what I'll do here, return if the string, so first I'll write it like a regular if statement, then I'll make it like the shortcut way. If the string dot character at the index, whatever the index is, equals my target, then return 1 plus, because remember that's the target, and I'm counting. So if I found it, then it's 1. That's one instance. So 1 plus, and then count character of string, the same target, except the index is +1. So we get closer and closer to our base case. However, else, if it's not the target, then we just return the count. We don't add 1, well, because it's not the target. But we still go past index, because the current index we're at is not the target. And that's about it. And so now, let me comment this out. System.out.print count. Why is it not showing? String, we'll say Jesus Christ, Lord and Savior. Okay, and then my target will have S, and my index will start at 0. Okay, now we gotta make this static, and let's see if this works. And it worked. It returned 4. So let's see if there's 4. That's 2. That's the 3rd. That's the 4th. So if I add another S here, that's 5. So what if for just one S, 1. If I pass an empty string, 0. And so there you go. So that works. Now the shorter way of doing this, you can say return str.character at index equals target question mark 1 plus count character string index plus 1, else count character plus 1. And there you go. That is the kind of one-liner, but both ways work. Okay, so that's that. Now we're going to be doing this last one. So if he brings questions like this on the midterm, you guys should be fine. I do have some advice for the midterm after we're done this. Like the best way to prep for it and make sure you're ready regardless of what he puts on it. Okay, so write a method. So let me make this static so I don't forget. Write a method that takes an array of integers and returns the most frequently occurring number in the array using a hash map. So whenever he says using a hash map, obviously the first thing you want to create is the hash map. The hash map will take key value pairs. What is the key is going to be the integer. And the other one is going to be an integer. This one is going to be the number in the array. And this one is going to be the frequency. All right. And we're going to call this frequency hash. Let's shorten it. Freq hash equals new hash map. And if you want, you can do array dot length to have it as the size. However, you can just leave it as the standard. I don't know how my brackets disappeared, but they did. Okay. So now that we have our hash map, we want a for loop. And this for loop will go through every number in the array and do what? So what we want to do is basically look in the hash map. If the number is there, then we increment whatever frequency it's at. If the number is not there, then we add it to the hash map and we put it as the default value of 1. So if freq hash dot get, remember the numbers are going to be the keys. And so if this does not equal null, okay, if this does not equal null, then what we'll do is freq hash dot put, obviously the key, and then we're going to say freq hash dot get num plus 1, right? And so the way this works is what I'm doing is if it's not null, then I'm going to add the key. And while if it's not null and you try to put a key that's already existing, it actually only updates the value. So what am I updating the value with? I'm updating it. Well, first I'm saying get num. This will return the frequency, right? When you say dot get and you give it a key, it will return you the value for that key. And in our case, the value for the key is the frequency. So I'm going to take the frequency and I'm going to add 1 to it because the value just showed up. Else, what I'm going to do, if the value doesn't exist, I'll do freq hash dot put the number, whatever number that doesn't exist, I'm going to add it now as a new key value pair, and the value is going to be 1 because that's the first instance it showed up. All right, and so now this will run through the hash. Let's say I give us an array of 5, 3, 5, 10, 3, 2. Okay, so what this will do is first we'll have obviously an empty hash. Then we'll go through the first number, and then we'll be like, search the hash. The hash will obviously return null. So we'll do frequency dot put the number 5 as the key, and the frequency is going to be 1. Then it's going to go again 3. Obviously same thing, 3 and 1. Then it's going to go 5. Dot get of 5 does not equal null because that will equal 1, not null. And so we'll do frequency dot put into 5, frequency dot get num, which gets you 1 plus 1. So then this gets updated to 2. And basically this will keep running until you get all the frequencies. Now once you get all the frequencies, what do you want to do? You want to get the maximum number of frequency. So we want to loop through the hash, find the maximum number, and then hold on to it. And then when we find the new maximum number, we replace it and we hold on to that. And so what we'll do is a for loop. First, we're going to need a variable that holds the maximum number. So int max number equals what is going to be our default maximum number. Actually, let me think. You can put it as the array at position 0. But that doesn't make sense. So I would say 0 because you can't have negative frequency. And you cannot have a number in the hash that is with a frequency of 0. Because remember, the lowest frequency you get is 1. You can't get 0 because if you found the number, that means that's 1, right? So we're going to set it to 0. Then I'm going to go a for loop. And what I'm going to say, how do I do this for loop? I want to go through every key, right? I want to go through every number. And then check the frequency. If the frequency of that number more than the frequency of, well, whatever your 0 is, then that would be, that would be the new maximum frequency, maximum number. But now I just realized if you set it to 0 and you try to compare if 5 at the frequency is more than frequency frec hash dot get of 0. So if we do in our comparison, because remember our initial value is maximum num. So if I do, for example, frec hash dot get max number to see, the frequency, my initial max number is 0, which doesn't exist. So I can do this and see, if it's not null, then compare. If it is null, then set whatever the number is to the maximum frequency. So what we'll do, what we'll do here is we will loop through the hash. How do you loop through the hash? We know it's numbers, right? The keys are the numbers. So usually you'll do key, but we know the key is the numbers. So what we'll do is if you do freq hash dot key set, this will return an array. This part will return an array of only the keys. So it will return basically this. Not in the same order, maybe in the same order, but that doesn't matter. It will just return an array with all the keys. All right? And so what will we do? We will go through each key. We'll do current frequency, current number frequency. So here, I'll write the whole thing. Current number frequency equals frec hash dot get num. What this does is we pass it the number, one of the keys, let's say it's the 5, and it will return the 2, which is the frequency of this number. All right? So now that we have that, we want to know if this is more than the current maximum number of frequency. So we can say, okay, if freq hash dot get of max num does not equal null, because remember at 0 it can equal null, and you can't put 1 or 2 or 3 because that might be not even in the array. Now one thing you can do, actually, we can do array at 0. That will always be a value that is within the hash. So then we get rid of this. We don't even need to compare that. So then what we'll do, okay, so freq, if the frequency of the maximum number is less than the frequency, well, if it's less than the current number frequency, right? If this is less than this, therefore this has a higher frequency, right? So we'll do that. So we'll do then the maximum number equals num. So I'm saying if the frequency of this number is more than the frequency of the current max, then obviously this number is the current max frequency. And so this will keep looping until for every number until it finds the max frequency. And then what we'll do is simply just return max num. Now there are ways you can optimize it. For example, I can take this and I can just set it here. That's one way. For max number, instead of doing the get here, what I can do is I can do this here, and I can make this array at 0, right? And then this one gets replaced with just max num. All right, and so that's basically another way to do it, like just optimizing or making it look nicer. Even for this part, you could, let me see. I mean, this part, it's easy for readability. Like you could change it. There's something called get at default, I think. It's, let's see, frequent hash dot get or default. And so this one, you can, here, let's see. If you hover over it, it'll tell you how to use it. So the parameter is the key whose associated value is to be returned. So you'll pass a key. The default value, the default mapping of the key. So what this, you can tell it is num. Your default value, we want it to be 1, right? That's going to be our, I think it's because num exists up here. There you go. So what this one is basically what I'm saying is get the frequency of num, and if it's not there, default that to 1. So that means I skipped this step basically. So that's in a faster way, but I like to keep you guys knowing less functions, like, because remember, you with get, put, key set, you can basically do everything all the other functions will let you do. The other functions are shortcuts, but that means there's more functions to remember, and you still have to remember these. So just remember these important ones, and you can do all the other ones. Now let's check if this even works. Most frequent number. So I have to create an array here. You know what? It's a good thing I have here a random generator. So I'll grab it. I'll put it down here. This is just a random number generator. So we'll generate an array. Int random array equals generate random array, and then we pass it a size. So if I want the size, let's do a size of 20, and minimum. So we'll say the values are between 0 and 10. All right, and so this will generate a random array between 0 and 10 that is a size of 20. Then we'll say most frequent, and we'll pass it the random array. And this will return us some number, and let's hope it works. So system.out.println, and there you go. Moment of truth. We got 5. Here, let's comment this out. And what I want to do is just do a for loop, a quick for loop to get my array, like to see what it looks like. So int num in random array. System.out. Actually, instead of that, I'll just do result equals string result equals that, and then what I'll do is I'll do result plus equals num. Does that work? Yeah, that should work. Except this, I'll define it up there. And then after it's done, I gotta add space after each one though. So result plus equals just space. We'll do a comma like that. Okay, and then now we'll just do system. Presentation matters, guys. Okay. Result plus a closing bracket. And so that should give us, so this is our little array. And as we could see, the most frequent number, 0, 0, so it gave us 6 as the most frequent number. Is 6 the most frequent number though? Doesn't look like it. 1, 2, there's only 2 of them. 10 is more frequent. What am I returning? Is it... I might have some issue then with my code. Oh, I think it's the least. So I think if I switch this, it will give me the most. If I'm not mistaken. No, it still gives me the least. Why is it giving the least? If the maximum number, so whatever at 0, if the maximum number is less than, oh, this returns a frequency. This doesn't return a number. This returns also a frequency. That should be fine. But I don't want the frequency here. I want the number here. So I guess my initial implementation was right. I don't want it to give me the number of frequency. I want it to give me an actual number. So this will be array at 0, and this will go back to frequency hash dot get max num. And so now here I'm comparing frequencies. This holds a number, and then my max will become a number. I'm not sure if that's even the problem, but let's see now. Oh, I think that fixed it. So you have 1, 2, 3, and 4. I'm gonna reduce the size just to make sure we can actually see. So let's reduce it to 5. The most frequent is 5. There you go. So that works. Now it's 10. That's 1. So you see for here, there's unique for everyone. So it just returned the 0 because they were all the same frequencies. That's about it. Is there any more questions? No? Okay, so some advice for the midterm. If you want to prep and you don't know what to write on the cheat sheet, or you don't know what to study, I wrote this to one of the students earlier okay, anyways, I don't even know why I was going to get into that. I got sidetracked. Anyways, so what I want you guys to do is write on cheat sheet. So this is going to be your cheat sheet. Cheat sheet. You're going to need source code for, this is the list, bubble sort. Okay, you're going to need merge. Well, actually, let me go in order. So that'll be selection, insertion. Let's make this bigger. Insertion. You're going to need merge. You're going to need quick, count. So these are the source codes you'll need for all these, like 100% put these on. And if you have space, put a binary search on, because that's a divide and conquer algorithm that he might actually ask. And we also did it in class. So that is just in case if he wants to get tricky. That's what you want to do. The second thing you want to do is write hash map functions. That means you need to know how to do the get, what the get returns. You need to get the put, how it works, how to use it, key set, contains. I believe I do have a list here. You also have a remove. For the contains, it contains key. That one searches if the key exists. There's also contains a value. You can search if a value exists. Size. Also hash code. Size. There's also one that's like key dot hash code. Gives you the hash code of a key. And there's one that's put if absent. I think these are the most important ones. I don't like this is extra. I don't think you'll need this. These, however, are definitely the most important ones, especially these ones. Okay, so that's what you'll need to put on your cheat sheet. Besides that, you want to write time and space complexity of all the above. All right, so that's what you'll need. If you watch all my lectures, you can take the notes all from there. Everything that's here is all in my lectures. What else would you need for your cheat sheet? Oh, no. So for this part, for sorting, know how to switch algorithm from ascending ascending to descending. Most of them are as simple, you switch this to this. Most of them. Okay? So you don't want to rewrite the whole code just for ascending and then rewrite the whole code for ascending. You write all your code in ascending. All that, make sure it's ascending, and then write a side note beside each one how to switch it to descending. Okay? So, because for example, if he gives you find the maximum value and you don't know how to do it in a recursive case, your best case, code up a merge sort it from biggest to smallest, and the maximum is obviously going to be at the end of the list if it's ascending. And if it's descending, it's going to be at array equals 0, at array index 0. And so that's your worst case, right? Like if your brain freezes, copy from your cheat sheet your code and just pick the last one for a maximum or a minimum question. At least you have something, right? So that's all you need. Besides that, I will 110% practice recursion for hard. So there's two recursion. Recursion on CodeBat, hard recursion, and normal recursion. Okay, definitely do those two. And that's about recursion. Look, my English lacks. That's about it. So that's all you really need. If you do all this, you watch all my lectures, you know the fundamentals, that's really all you need to at least get an 85, 80 plus, like 100% guaranteed. So good luck on the midterm, guys. If anybody has questions, message me on Instagram, on Discord, whatever, comment section. My account on every platform is RHXRR. So if you ever want to message me somewhere, if you just search RHXRR, I'll probably pop up. So that's it. Hope you guys have a good day and a good midterm, and I'll see you guys in the next midterm for whatever course.